Okay, we're on part 2 of concentration, code, and hints. Let's get started. When you run it, this is what you see, as you know. Let's talk about how you're going to approach building this. What you should not do is go through the functions one at a time and write each one to completion. It's the wrong way to do it. Instead, as a general approach, what you're going to want to do is write individual features and get each feature working one at a time. First, just get the grid displaying. Then just put the numbers in the grid. And then be able to, for instance, view those numbers. Then after that, you'll probably want to add the ability to, for instance, select one cell. Just get to select a cell. After that, you probably want to be able to ability to select a second cell and judge if you're right or judge if you're wrong. But you would be doing this incrementally, bit by bit, and getting each piece working before you move on to the next piece. Okay. With that said, let's start talking about some of the actual functions. So again, even though you're not going to write them in completion in this order, we're going to talk about them in this order. So init. So init is going to, of course, initialize the values in your data and your board game. Okay. There's a couple things we might want to talk about here. We're going to have to track our guesses. So we'll set a guess count to 0. We also track the number that we found. We store that in data.foundCount. And when you find a new one, of course, we increment that. When you find all 16 pairs, that's how we know that you're done. We also stored data.selections, which stores a list of the cells as the values that are in the board game list, a list of the cells that are selected. So when you start the game, it's actually data.selections is empty, but now it's going to have this one cell in it. And now it have these two cells in it. Okay, that was handy for us. And we also stored data.selection color. That's handy. So like right now the selection color is yellow, and now the selection color is pink. Now it's yellow, and now it's green. So that's handy. So when you decide that like there's a match, you can just set the selection color immediately. Now what I want to talk about now is the harder part of data.init, I believe, and that's loading the board up of values. So you have to load the board up with 32 values so that every single integer from 0 to 15 is there twice. Okay. So to do that, first, let's create just a list of values. It seems like we want to do range of 16, okay? But if we print that, we don't really get a list. How about values? We don't really get a list. You have to also convert it to a list. And now we have the list of numbers from 0 to 15. If we were to multiply that list by 2, now we have the numbers from 0 to 15 all twice. 0 to 15 and then 0 to 15. Those are all the values we want. The only thing is we want those to be in a random order. Well, happily, if you import random, which is done for you in the file, in the starter file for homework 5, you can use random.shuffle, and that will go ahead and shuffle those values. And so now we create 0 to 15 twice, and shuffle them, and these now are randomly ordered values that we want. The trick now is to take these 32 values and lay them into this grid. No problem. You just loop for each row in the grid, for each column in the grid. And how do you know the rows and columns of the grid? Well, mind you, data.boardGame holds the entire game, and .rows is the number of rows, and .cols is the number of cols. Cool. Then, as you're looping, you want to pull out each cell. Remember that the cells are in the board game's board, which is a 2D list. So you use the row and col as the indices, and now I've pulled out the cell. So finally, what I want to do is with that, I want to set the cell's value to equal the next value out of this list of values. Okay? And how would we do that? Well, if I have values, I can do values.pop. And it pulls off the last value in the list, values.pop, pulls off the last value of the list. So I can just loop over this in a 2D way for each row, for each column, and set cell.value to the next value in the values list by popping it. It's a pretty detailed explanation of what's going on there. We also recommend that you print out the values as you're doing this in your console. Because then you can like look, you can't see right here, but if I turn these values off, I'll go here and turn them off. I still can see over my console the values. Like I know there's a 1 here, and I know there's a 1, what is it, right there. And so for debugging purposes, that's very handy. Okay, so that was init. Let's continue on with cells match. So cells match is a simple little function. It takes two cells and tells you whether they match, okay? So here's the thing. This cell right here matches that cell right there. And so all you want to do to tell if two cells match is make sure that they have the same value, basically. The only catch is a cell should not match with itself. So two cells match if they don't have the same row and column, so they are actually different cells, and they have the same value. Mind you, also, when you have a cell, Board Game will load up cell.row and cell.col for you, holding the row and column of that cell. Cool. Okay. Proceeding with Mousepressed. So in Mousepressed, we have to basically get the cell that you clicked on. Okay, when I press the mouse, I will use get cell. That comes with Board Game. And I give it the board game, the X and the Y, the event, and it gives me back the cell I clicked in, if any. Like out here, I'm not clicking in the cell. Okay. Then I want to check if I actually clicked in a cell. So if cell is not none, and if I clicked in a cell that's not green, mind you, we're going to use cell.isFound. We're going to use cell.isFound, which will be false in our init. Okay. And we'll set it to true when we actually find a cell. So if I go 14 here, right now that cell is found as false, but if I were to find the matching one, which looks like it's there, then the cell is found as true of each of those. Anyway, when I click in a cell, if it's found, like I'm clicking here, nothing happens. If it's not found, so and also it's not in the selection, then select it. So if I click in the selection, nothing happens. If I click in found, nothing happens. If I click outside the board, nothing happens. Otherwise, bam, I make another selection. And what do when you want to make a selection? Why, you don't do anything in Mousepressed except call select cell, which is its own function that we're going to write. The reason for that is we're also going to select cell in Autoplay later on. So Mousepressed will call select cell, and later on Autoplay will call select cell. Okay, so now we know that you want to select a given cell. How do you do it? You do it in select cell. So let's look at select cell for a minute. Okay. So in select cell, you have to append the cell to the data.selections list of cells. So if I select, when I'm selecting a cell, I put it into the data selections list. Make sure that list never has more than two values in it. Okay. All right. So now there's two possibilities. There's either one value in it or two values in it in the data.selections. If there's just one, there's nothing left to do. If there's two, well, when after you selected the cell, you have to check what just happened, if something good or bad happened. And for that, we're going to use the cells match function that we wrote above. When we select two cells, we're going to call cells match. And there's two possibilities. They match or they don't. Okay, and if they don't match, then all you have to do is note that the well, in fact, there's really nothing much you have to do. It's when they do match that you have to do something. So if they match, if I were to click on, say, here and here, these are going to match magically. I just know that. Okay. And of course, I knew it by looking at the output in my console. Now, because they matched, I had to mark them both of their isFounds as true, cell.isFound. And remember that I just got another match by incrementing our found count. And then finally, if we won, I have to deal with winning by changing this message right here and by noting that the game is over. Okay, that's all. So that was select cell. Restart and sort values. So this is actually handy for debugging purposes. If I hit S, it restarts and sorts the values. I don't think that there's a lot to discuss there, except to restart, you just call init again. And then to load the values, you're going to have to iterate or loop over each row and each column, and maybe have a counter that's increasing. And when the counter gets up to 15, send it back to 0, something like that. Okay. Key pressed, very straightforward. Key press does almost nothing, right? If I press R, it'll restart the game. You know how to do that calling init. If I press S, we just talked about restart and sort values, so just call that function. If I were to hit V, we'll toggle, V is to view all values. We'll just toggle data.view values or something like that from true to false and false to true. Okay. And of course, show numbers, the same deal. Okay, so you're just toggling value data.show numbers. Finally, the interesting one probably is autoplay. If I were to hit A right here, A. Now, if you hit A, you're going to do autoplay. We recommend that you don't put the autoplay in keypress, but you call the autoplay function. Get some of that functionality out of keypress so it doesn't get too big. Which brings us to autoplay. Okay, there's three possibilities in autoplay. One possibility is that the game is over. And if I autoplay right now, all I do is reinit, just call init. So it just restarts. The second possibility is, as you see here, the game's not over and no cell is selected. So in that case, you want to select a random cell. The way we're going to select a random cell is by using random.randrange to choose a random row and to choose then a random column. And then we're going to look if that cell is found. Okay, so if I were to, for instance, let's say I was right here, and then I happen to randomly choose this cell. Since that cell is found, we can't use that as the random one to select. Okay, so what we'll do is we'll do this inside a loop, inside an infinite loop, while true. Pick a random row, pick a random column. If it was found, oh well, just keep looping. If it's not found, then that's great. Go ahead and select the cell, and we're done, so return. How do you select the cell? Well, by calling the select cell function that we wrote above. That was handy. Great. Okay. So now we said there's three possibilities. You hit A when the game is over. You hit A when there's no selection, or like now you hit A when there is a selection. When you hit A when there is a selection, you just have to loop over all the cells and find the cell that matches that cell. Well, we wrote cells match, so you probably want to use that to check. And when you find it, we wrote select cell, which you would just call to go ahead and select it. So there's not too much to that, but you do have to use the standard nested loops to loop over all the cells for each row, for each column. Cool. Okay. Continuing, that brings us to draw cell value. Well, here we're going to give you a bigger hint than we normally do. We're going to actually give you the code in the video. We're not going to actually include the code in the starter file, so you're going to have to still type it in. And the reason for that is we hope that it leads to maybe a little heightened understanding, that you think about it a little more as you go. Rather than if it was in the starter file, maybe you would just kind of ignore it. I think that's a natural thing to do. So to draw a cell value, it's going to take the canvas, data, cell, and bounds. So it's called on a single cell, and so in the canvas and the data, it's given some cell, and it's given the bounds of the cell, the x0, y0, x1, y1. Okay? And here's what we expect you to do. So will your code wind up looking like this? We would highly suggest it. So long as you pay attention to this video and understand what this code is doing, we would expect your draw cell value to basically match this identically. Okay. So to begin with, we find the center of the cell, Cx and Cy. Okay. If we are showing numbers, there's almost nothing to do. Just go ahead and draw the number that's stored inside cell value. So that's easy. The hard part is if we're not drawing numbers, but we are drawing shapes. Okay, and let's go view all values. We're drawing shapes. Okay, let's actually now sort and view all values and get out of numbers. Okay, so now we need a way to convert numbers into shapes. Okay, and to do that, we realize the numbers go from 0 to 15. Now that happens to be interesting because 0 to 15 has 4 bits, right? So the largest 4-bit number is 1111, which in binary is 15, and the smallest is 0000, which is 0, right? Okay, so what we're going to do is we're going to take the cell's value and we're going to pull out each of the 4 bits that make up that value, and these four lines of code do that. So if you think about the value, say 13 in base 2, that's 8 plus 4 plus no 2 plus 1, right? So when you take that value mod 2, you're going to pull off that bit right there, the 1's bit. And that's why bit 0 is the value mod 2, the remainder when we divide by 2. Now to get at this second bit right there, what we do is we first divide by 2, which gets rid of that first bit, and then we mod 2 to get the 1s. That's why the bit 1 does this. To get at the third bit, we have to divide by 2 again, which is to say to divide the whole value by 4, which gets rid of the lowest 2 bits. Mod 2 picks up that bit, and that's the pattern. So now we have each of the 4 bits, and these are just zeros or ones, okay? And we have to turn these into the graphical properties we need in order to draw. First, let's do the color. The top 2 bits are going to decide the color, and the colors are red, orange, green, or blue. There's 4 colors, so we need 2 bits for that. And so what you do is you turn 2 bits into an index into here. So if they are 0, 0, we'd be red. If they were 0, 1, we would be orange. 1, 0 will be green, and 1, 1 will be blue. So we need an index into this small list, and the index is computed this way, right? So if bit 3 is the high bit, so it's like the 2's digit. Bit 1's the low bit, so it's the 1's digit. So that's where this math comes from. In any case, this color index is going to be a value from 0 to 3, depending on these 2 bits, and it's going to pull out one of these 4 values. Now you can see this you can see this happening here if we go back here and we view. Nope, I'm sorry, we do that. Okay, so the order in the code was red, orange, green, blue. Red, orange, green, blue. Okay, and let's actually look at the numbers again. The first 4 numbers are red, the next 4 numbers are orange, the next 4 numbers are green, the next 4 numbers are blue. Okay, that's the net effect of what we just did here. Great. Okay, now we have to do, and by the way, we just set our fill color to that color. Now we're going to look at bit 1. Okay, bit 1 is the 2's bit, actually. It's because the 1's, 2's, 4's, and 8's bit. And bit 1 is going to decide if the outline is in black or not in black. Okay, so here if we were to go back to the numbers, the ones that have outlines in black, 2 and 3. And here again, 6 and 7. So you see, these are the ones that when you represent them in binary in base 2, they have a 2-bit that's a 1. And finally, we have to decide if we're going to be an oval or a rectangle, and we use the ones bit, the ones bit for that, the rightmost bit. So if it's a 1, the odd values are ovals, and the even values are rectangles. Even, odd, even, odd, even, odd. Of course, ovals are circles, right? And the rectangles are squares. And taking all of this together, that's how we were able to convert a value into the properties of one of 4 colors, whether or not you have an outline, and whether you're a square or a circle. Cool. Which brings us finally to draw all. So draw all is going to do a fair bit of work. You have to draw your title and the directions, and you have to draw the board. Don't forget to do your nested loops for each row, for each column. Grab the cell out of the data.boardGame board, and then determine the color of the cell. If it's found, right, then the color is going to be green. If it's not found but it's selected, then the color is going to be yellow. If it's not found but there's 2 selections, then it'll be pink. Draw the background, and then to draw the foreground, so the background is just a rectangle some color. The foreground is what draw cell value did. So we've actually done the hard part, the foreground. And of course, handle game over appropriately as well. That's a very detailed walkthrough of everything you need to know. This should hopefully make the code significantly easier to write. And one last point is for the bonus. We sure hope you do it, because here, to draw these shapes, we've basically given you the code. But there are static shapes, and there's an opportunity here to do something really cool and fun. So instead of, say, having bits tell you that there's a border, you could have this be animated. So for instance, maybe instead of a border or no border, they're moving around the perimeter, or they're moving in a circle, maybe the shape is inside its cell. And maybe the what you're picking is whether it's going to move clockwise or counterclockwise. Okay, so you'd have to match the counterclockwise movement to the counterclockwise movement and the clockwise movement to the clockwise movement. You can actually invent your own animations. We sure hope some of you do. That's a fun and reasonably challenging bonus. If you don't, that's fine. That's why we call it bonus. Hopefully this is enough to get you going. I apologize for the length of the video, but we believe by giving you a nice long detailed video, we're actually going to make the homework take a lot less time. That's our hope anyway. We hope it works out that way. We're still here for you on Piazza and office hours if you need help. Good luck with it. Have fun.